Okay, so today what we're going to be doing is we're going to be combining two things that we learned last week. Okay, we talked about parent functions. We learned the 10 parent functions. Okay, and we also talked about transformations of functions. Okay, remember when we did that assignment, that 1.9, we said the transformations that we talked about apply to every function no matter what. So that includes these parent functions. Okay. So we're going to be combining the parent functions that we learned and the transformation rules, and we're going to be transforming parent functions. You'll see that Unit 2 is really just an extension of Unit 1. Okay? We're really just building upon ideas that we learned last unit, and the Unit 2 test is really Functions Test Part 2. So it's going to have a lot of stuff from Unit 1 as well. Okay? So these two units are very, very interconnected. Okay? So let's go ahead and look at this. Right? We are asked to graph y equals negative 2x, the square root. All right, one more time. Y equals negative 2 times the square root of x plus 1 minus 5. Okay? Exactly. That little tail at the end of the square root just means that this is where my square root ends. The negative 5 is not included. Okay? Okay, what is the parent function of this equation? Okay, function, I need an equation. Good. Y equals the square root of x. Okay? So let's remember what that graph looks like. Where does it start? The origin, good. Okay? And it kind of like curves over there. Okay? What's the domain? Good. What about our range? Same thing. Okay. So, remember when you were listing out the transformations? Okay? We talked about that the order doesn't really matter when you're listing them. But when you're graphing, the order is very, very important. Okay? The order is very important when you're graphing, so you got to make sure that we're working from the inside out. Okay? So, what's the first transformation you think we're going to do? Okay, over which way? Left. Left 1. This plus 1 is the first thing we deal with. Not yet. Okay. We're going to come out here. We do have to deal with this negative 2. But one thing you guys kind of forgot on your test, all right? This negative 2, that is not just one transformation. That's two different transformations. So what are we going to do first? What's closest to the x? Vertical stretch of 2. Okay? Yeah, now we're going to deal with that negative. What does that negative do? Reflects across x. Down 5. Okay? Yeah, kind of.
In this situation or in all?
It's not a bad question. I just need to think about it. So what you want to think of is that your parent function is the square root of x. Okay? So anything that you're taking the square root of is essentially in your parentheses, because that's what's inside the function. Anything that's outside the square root, you're doing to square root of something. So you're applying it to the whole function. So that's like outside your parentheses. Okay? Okay. All right. We're going to graph this in 5 steps. Okay? We're going to start with the parent function. We're going to graph each of the transformations. Now, you are not always going to have to do this. Okay? You're going to get better at this. But as we start, we want to do it step by step by step. Okay? So the very first thing I want to graph is the parent function. So the first thing I'm going to graph is y equals the square root of x. Okay? So I know we have a point at 0, 0. Where's my next point? 1, 1. And where's my next point? Bless you. Okay. Let's now do our first transformation. Our first transformation is left 1. So what I'm really going to be graphing here is y equals the square root of x minus 1. So we're going to take each of our points and we're going to move them left 1. So 0, 0 is going to become 0, negative 1. 1, 1 is going to become 0, 1. And 4, 2 is going to become 3, 2. I took my whole graph and I shifted it to the left. Okay? What are we going to do next? We're going to do the vertical stretch, so we're going to do 2 times the square root of x minus 1. Now, if I'm talking about vertically stretching, am I manipulating the x values or the y values? Y. Y goes with vertical. Okay? So, what I'm going to do here is I'm going to take each y value and I'm going to multiply them by 2. Okay? That's how you do a vertical stretch. Take each y value of your point and you multiply them by 2. Okay? So what happens to negative 1, 0? Stays the same because what's my y value? 0. So that one's going to have to stay the same. What about 0, 1? 0, 2. What about 3, 2? What does that become? 3, 4. I take my y value and I multiply it by 2. Questions? Okay? So this was C. Let's do D now. A reflection across the x-axis. Okay, so now I'm going to graph y equals negative 2 times the square root of x minus 1. Right? What happens to the point negative 1, 0? What am I reflecting across? The x-axis. Okay? The negative is outside of the function. The negative is affecting your y values. Which way do you flip if you want to affect your y values? You're going to reflect across the x. Okay? So in this case, this point's going to stay the exact same. How about 0, 2? Oh, I'm sorry. You're exactly right. We've done it all correct. This is just supposed to be x plus 1. I've just miswrote it. I apologize. Those are supposed to be x plus 1s. We've done everything we've done is correct, but those are supposed to be x plus 1s. Okay? All right, so 0, 2, what does that become? 0, negative 2. How about 3, 4? Okay? And our last step, what are we going to do? Down 5. Okay? So we're going to take our graph and we're just going to shift everything down 5. So negative 1, 0 is going to become negative 1, negative 5. Zero, negative 2 is going to become 0, negative 7. And 3, negative 4 is going to become 3, negative 9. I'm sorry?
So it just starts below the graph. Never mind.
I just didn't understand. You can ask again.
Nothing. I was just nothing. Never mind.
Are you sure?
Yes, I'm positive.
Okay.
I get it now.
Okay. This is our final graph. This is it. This is y equals negative 2 times the square root of x plus 1, all minus 5. What's the domain of this new graph? Negative 1 to infinity. What's at negative 1? Bracket. What's the range of this new graph? Okay, it's tempting to say negative 5 to infinity. But remember, in interval notation, we go from the bottommost number to the topmost number. So what's the bottommost y value? Negative infinity. So here we're going to go negative infinity to 5, or sorry, to negative 5. What's going to be around negative 5? Bracket. What questions do you have? Yeah, Emily. For the range? For the range? Domain and range? Okay, so we're looking at this. Let me move this up. This projector is kind of blurry. Okay, so we're looking at this, our final function. Okay? So we're not worried about any of the domains of anything else. We're just worried about this domain. So for our domain here, we're going to go leftmost number to the right. There's not an asymptote. There's just nothing over here. There's no arrow telling me it goes over here. There's no shift going over here. The only way this graph is moving is to the right.
Okay, I see now.
Okay, good. Someone else had a question. Stuart?
I just don't get how to get, like, the numbers,
Which numbers?
like the points on the graph.
Okay, you have to know the points that you're starting with. So when we started with our graph, we had 0, 0, 1, 1, and 4, 2. Okay? And then as we were moving, we went left 1. So we took each of those points and moved them to the left one. And we just kept manipulating those 3 points the whole time.
And on C, you multiply both by 2.
Both all the y values by 2. A vertical stretch multiplies your y values by 2. Okay? Let's keep going. Oh, real quick. It is really important that you double check some of your work. Okay? What's a way without a calculator that I could double check that I did this correctly? A table. Yeah. I could take, let's say, x equals 0. Okay? And I could plug that in. And what should I get out when I plug in 0 for x? What's our y value here? Negative 7. So let's try it. If I plug in 0 for x, 0 plus 1 is 1. Square root of 1? 1. 1 times negative 2? Negative 2 minus 5? Negative 7. Okay? It's really important at the end, because think how many steps we went through and how easy it would have been to go the wrong way or to mess up or something. Right? It's really important at the end. Pick one of your points on your graph, plug in the x, make sure you get out the y you had. Okay? Okay. Here's number 2. Can you go through it? Okay. Nope, we're still going to do it together. Okay, y equals 1/2 x cubed. Very first thing we always have to do is decide our parent function. What's our parent function? Thank you. Y equals. I heard it. I was just waiting for a couple more people to jump on the bandwagon. Y equals x cubed. All right? So what is the shape, just real generally, kind of draw it in the air, what does the shape of x cubed look like? Yeah. It's like your long S. So sketch yourself just a little mini version. We're going to graph it in just a minute. What's the domain of x cubed? Yep, negative infinity to infinity, all real numbers. What's the range? Same. Okay. How many transformations do we have? 1. What's the only thing there that we have to deal with? That 1/2. Okay? We have to deal with that 1/2. And I already heard what that does. What does that 1/2 do? It's a horizontal stretch. It's a horizontal stretch. Okay, now let's think about this. We see a fraction in there. What does our head tell us we want? Instead of a stretch, what would we think would happen? A compression. So remember, when it's inside the parentheses, it does opposite what you think it's going to do. Okay? Stretches or compressions and shifts are going to go opposite what you think inside the parentheses. So that's why this is a stretch instead of a compression. Okay? So let's go ahead and graph our parent function. Go ahead and plot a couple points here. We know we've got 0, 0. What's another point? 1, 1. What's another point? Negative 1, 1. Not 2, 4. 2, 8. Good. So as you can tell, it's really important that you're super comfortable. Well, that was awful. That you're super comfortable with these parent functions. Okay? You need to know points. You need to know shape. That's why we had you memorize them. Because if you don't know where to start, you have no chance of being able to graph it. All right? Okay. Now let's deal with that horizontal stretch. So now I'm going to graph y equals 1/2 x cubed. Okay, a horizontal stretch by 2. Now when I say horizontal, are we going to be manipulating the x values or the y values? The x values, okay? So I'm going to be manipulating the x values. What I'm really going to do here Okay? I've got a 1/2 here. I'm looking at this 2. I'm really going to multiply x values by 2. That's what a horizontal stretch of means with a 1/2 in there. Yes?
Could you explain how? Sorry, I still don't get why you're multiplying them by 2.
Okay, it's a horizontal stretch. It's doing opposite what we think. So really what we're doing here is we're dividing by 1/2. But dividing by 1/2 is the same as multiplying by 2. Okay? If there were a regular 2 in there, we would take all our x values and divide them by 2. And that would give us the compression. Okay? All right, let's graph it. Does 0, 0 change? No. How about 1, 1? Is it going to be 1, 2 or 2, 1? 2, 1. Great. What about negative 1, 1? Or sorry, negative 1, negative 1. Good. Negative 2, negative 1. 2, 8. What's that going to become? 4, 8. And once you draw it, you can see how our y value stayed the same, but we stretched it horizontally. What's the domain of our new graph? Still all real numbers. What's the range? All real numbers. If you're performing transformation on a parent function that has a domain and range of all real numbers, it will still be all real numbers. Questions? Great. Let's do another one. This will be our last one. Okay. Looking at this, what did we always know the first thing we have to do is? What do we have to decide? The parent function. We got to decide the parent function. What is the parent function here? Good. Y equals the absolute value of x. Okay? When we did assignment 1.9, and we did all those transformations, we used the calculator and everything to kind of find some stuff out. We talked about the absolute value as a operation, okay, as a transformation. We did the absolute value of some function, okay? This is different. This is the absolute value as a parent function. So the starting shape we're starting with is that v, okay? Does everyone see the difference? All right. So tomorrow we'll talk a little bit more about absolute value as a transformation, as an operation. Okay? So we know that the absolute value parent function looks like a v. What's the domain? What's the range? Okay? Okay, let me preface this by saying this is, in many ways, what we're going to do here is an exception to some rules. Okay? It's good to show every now and then. The rules don't always stand. They stand most of the time. You have to learn them. But there are some exceptions to the rule. This function is an exception to a couple of our rules. Okay? You're not going to like it. I don't like it either. But we're just going to accept it and we're going to go with it. Okay? All right. The first thing you have to accept with this function, notice that inside our function, inside the absolute value, so kind of inside the parentheses if you think about it that way, we have a reflection and we have a shift. Okay? We have two things happening in here. When that's true, when on the inside you have a reflection and a shift, you have to rewrite this function so that reflection is working on the whole inside. Okay? So what I'm going to do is I'm going to my pen stopped working. Okay, sorry, it just froze for a second there, it looks like. Oh. There we go. Okay, I'm going to pull out the negative from the inside. I'm essentially going to factor out a -1. Okay, because I have to accept that this negative is working on the whole inside of the function. So if I were to pull out this -1, I would be left with x what? -2. Okay? Because if I were to distribute this negative, would you agree that I would get -x plus 2? Yeah. Okay? So that -1, sorry, my pen just died. Give me 1 second. So -1. Sorry about that. All right. This is one of those things, I know it's weird. I know it doesn't make a lot of sense. But the idea is that that reflection is happening to the whole inside. So I have to do that. I have to take it out. Okay? All right. So let's list our transformations. Okay, here's the next thing you're not going to like. Normally, we would start closest to the x, right? And we would start with right 2. Would you agree? Okay. This is one of those exceptions to that rule. If there's a reflection on the inside, you have to start with that reflection. So the first transformation we're going to do here is that reflection. Okay? What are we reflecting across? Good. Okay? Then we're going to go to that 2. And what's that going to have us do? Okay, we're going off of this one. Right 2. Okay, then what are we going to do? Down 1. Okay? So, let's start with y equals the absolute value of x. Tell me some points on that graph. 0, 0. -1, 1. 1, 1. 2, 2. -2, 2. And I could keep going. All right? What is my first transformation that I'm supposed to do? Reflect across the y-axis. So essentially what I'm graphing is y equals the absolute value of -x. Well, what does that look like if I reflect the absolute value across the y-axis? It's the exact same. Is that always going to be the case? Nope, just happens with this parent function. All right, what's the next transformation I'm supposed to do? Right 2. So what I'm going to be graphing is the absolute value of negative x minus 2. So that's going to take my whole function and move it right 2. So 0, 0 goes to where? 2, 0. And then we're going to have 3, 1, and 1, 1. Okay, and what's our last step? Down 1. So our last step is to graph the absolute value of negative x minus 2 minus 1. So we're going to take each of our points and just move them down 1. That's our final graph. How can I check that I didn't mess up an order somewhere or got something mixed up because this was such a weird problem? Yeah, let's plug in. Let's plug in 3. Okay? When we plug in 3, what are we hoping we get out? 0. All right. So plug in 3 for x. 3 minus 2. 1. Negative 1. Absolute value of negative 1. 1 minus 1, 0. Now, that's the equation we, shifted around. Let's go back to the very, very original equation. Let's try plugging in 3 up there. So if I plug in 3 up here, what do I have? Negative 3 plus 2 is negative 1. The absolute value of negative 1, 1 minus 1, 0. So I haven't lied to you. It does work. Okay? Little weird, I understand. But that's why we wanted to do it with you so that you could kind of see what happens. Okay, let me pass out your homework. You have some time to get started. On your homework, okay? This is what your homework looks like. What I want